All right, my friends, let's take a look. For this first one, whether in your head or on paper, you think you could split this into two integrals over the addition there. So you could factor a negative out also. And, you know, whether you showed these steps or not, this likely kind of happened in your head. Anyway, and then you could think about substitution on each one. And since your du would equal your dx, really I hope it makes sense. You could just apply the natural log rule to each one. So for the first one, you'd have natural log of x plus 2, or the absolute value that is. And for the second one, you have 2 times the natural log of the absolute value of x minus 3. And then don't forget plus c. Okay, again, you could show you substitution to make sense of that as well. All right, my friends, for problem 2 here, where you add the fractions together, I am going to show more work than you probably did or than I normally would. And the reason for that is because we really need to be so good at this procedure of adding fractions that we can undo it, because partial fraction decomposition is where you take the answer that we would get to a problem like this, and you work back and figure out what were the two fractions that were being added together to get your answer, okay? If you're good at adding fractions, you're good at unadding fractions. I hope that makes sense. So whether you thought this in your head or wrote it down, oops, let me get that cursor out of there. There we go. You would take the first fraction, let me move that negative so it's more obviously in the top there, and you'd multiply it by a creative version of 1 that helps you get the least common denominator between the two fractions. And then you take the second fraction and you do the same thing with that. There we go. All right, and then from there, you could just distribute. You'd have negative x plus 3. And I hope it makes sense that since you now do have common denominator of the quantity x plus 2 times the quantity x minus 3, you can go ahead and merge the denominators together. There we go. And then combining like terms, we'd end up with, what would that be? X plus 7 over, and if I distribute the bottom out, which sometimes that benefits you, sometimes it doesn't, but let's go ahead and do that this time. So x squared minus x minus 6. There we go. And maybe now you can see where we're going with this. In this lesson, our goal is going to be to integrate rational functions that look like what you see in this third warm-up. And so the idea is I set you up so hopefully you could see that this integrand, since it is the answer that we just got when we added these two fractions together, I was hoping that you could see that you could kind of decompose this rational function here as you could replace it essentially with the two fractions that we used to get it. And this whole lesson is about really like that process for how do you decompose fractions? How do you get that answer? So anyway, because once you can decompose a rational function as two simpler fractions, then you have an easy problem like warm up 1 here. And so you could get the answer nice and fast. There we go. All right, my friends. So the rest of the lesson, honestly, is just focusing on how do you do that process of partial fraction decomposition. And I know that in Accelerated Pre-Cal, this was part of the curriculum. It doesn't especially mean that you remember how to do it. And I know we have some folks who have transferred in and maybe you don't have this background. So this lesson should help you with that for sure. So, all right. So I am, for example 1, you can see I am recycling from the warm-up. So you should already know the answer, right? Like x plus 7 over x squared minus x minus 6. Like, how did we get that? Okay, so this is the answer, right? Okay, but now let's talk about kind of a procedure for how to get the answer if you don't already know it. So for this one, I'm going to show more steps than I usually would, and then at some point I'll start skipping steps, and it's up to you how many steps you want to show or not, as long as you have something that works for you. So step 1, my friends, is to factor the denominator. So hopefully you're good at factoring. Okay, step 2 is to write what's called the form of the decomposition. And this is what's called, if you look at the factors, x minus 3 and x plus 2, they're both linear, meaning degree 1, and they're both different. So this is what's called a distinct linear factors case, and this is the simplest one. So the form, my friends, would be a constant over x minus 3 plus a second constant over the other factor, x plus 2. So just to make sure you're clear, this is called writing the form of the decomposition. There we go. Okay, now the next thing you do is act like you're adding the fractions together. So you could take the first fraction and multiply it by a creative version of 1 that it would take to add the two fractions together. So I have switched modes from kind of breaking it apart back to adding things back together. Okay, and then once you get to here, you could see that you do have common denominator on the bottom. And then you have this super fun expression on the top. So you've got ax plus 2a plus bx minus 3b on the top. Now, hopefully you're using the format I'm using where you've got your equal signs lined up. And the reason for that is because I'm going to bring down this fraction that you started out with, and I'm going to line it up with this last line that I've got. So let's think about this. If these fractions are equal to each other, and I have made sure that the denominators are equal, then in order for the two fractions to be truly equal, then the numerators would have to be the same. So I think of partial fraction decomposition as two battles. Battle number 1, make the denominators match, which I've already won that battle. And then battle number 2 is, once you've won that battle, then battle number 2 is to make the numerators match. So at this point, you're going to see me not write the denominators anymore because I already made those equal each other. And you're just going to see me set the numerators equal to each other. Okay, now from here on the right side, you're going to group the x terms together. And I recommend factoring that x out, and I'm going to factor it out on the right side. So you'd have a plus b x's. And then the other terms, the terms that don't have x's, those would be grouped together as constants. And then for the x plus 7 that you see on the left side, let's write it as 1x plus 7. And why did we do that? Because if we want these two expressions to equal each other, then the number of x's on the left side is 1, and the number of x's on the right side is a plus b, which means that we would need a plus b to equal 1. And the constant term on the right side is 2a minus 3b, and the constant term on the left side is 7. There we go. At this point, you get to solve a system of equations, and we all know that there are lots of ways. There's substitution, elimination, and graphing. Whatever works for you. We all know there are different ways to do it. So let's see, what do I want to do? I'm going to multiply row 1 by 3. So I'm going to do 3 times row 1. And then I'm just going to add it to that row 2 as is. Actually, yeah. Okay, and I'm going to have 5a equals 10 by adding the 2 rows together. And then I'm going to divide both sides by 5. And I just found out that a is 2. And now that I know that a is 2, I could always back substitute into either row. I like row 1 because it's cleaner. And it would say 2 plus b equals 1, which means b would have to be negative 1. There we go. Once you've solved for your two constants, all you do is take them and back substitute into your form. And so we're just going to write that form with your a and b values subbed in. So we would be able to conclude that x plus 7 over x squared minus x minus 6 is the same as 2 over x minus 3 plus negative 1 over x plus 2. There we go, my friends. And that is the method known as partial fraction decomposition. All right, my friends, let's move on to example 2. I have two parts here. Both are integrals. Go ahead and see what you can do with those. I'll give you a hint. This is in the lesson known as partial fraction decomposition for a reason. Anyway, so see how it goes and then check in with me in the next video. Good luck.